Welcome to the third video in our lesson on patterns and relations in tables. So let's consider some more patterns here. So while playing with connectors, Joy created the following shapes. We have to complete the table to determine the relation between the diagram number and the number of connectors used. So in the first diagram, how many connectors were used? Let's see, 1, 2, 3, 4, 5, 6, and 7 connectors in the first diagram. In the second diagram, I count 12 in total. In the third diagram, there are 17. And in the fourth diagram, there are 22. So now to determine the relation, let's start by looking at what the output values, or the C values, increase by. 7 to 12 to 17 to 22, they all increase by 5. So we can start off with the equation C equals 5 times D. Next we plug in a value for D, and we can just use 1. 5 times 1 is 5. And looking at the table, we should have a value of 7. So what does that mean to our equation? What are we going to do? We're going to add 2. So that means our equation is C equals 5D plus 2. Now for part B of this question, it says, use the relation to determine how many connectors would be needed to create the ninth diagram. Well, here's our relation. So what we would do is replace D with 9. So 5 times 9 plus 2 is what we need to simplify here. 5 times 9 is 45. Adding 2 onto that gives us 47. So that means in order to create the ninth diagram, Joy would need 47 connectors. Now for this next example, it says, when Shema examined the table of values below, she wrote the relation as B equals D plus 3. Determine if she is correct, and if not, write the correct relation. So we can check this by simply plugging in a value for D and see if we get the corresponding B value. So we can start by replacing D with 1. So we just need to add 1 and 3 together, which gives us 4. Now looking at the table, I see that D corresponds with 3, not 4. So that means no, Shema is not correct. So now we're asked to write the correct relation. So we always start by looking at the output values, which are B in this case. Let's see what they increase by. 3, 6, 9, 12. They all increase by 3s. So we can start off by saying B equals 3 times D. So it looks like Shema added 3 onto D as opposed to multiplying D by 3. So now we got to see if there's a number that can be added or subtracted onto this equation. So again, we just plug in a number for D. In this case, we can just use 2. B equals 3 times 2, which is 6. Now looking at the table, when D equals 2, B does equal 6. So that means we don't need to add or subtract anything onto the equation. So we can say that the correct relation is B equals 3D. So that concludes section 3. Be sure to complete all the activities before moving on to the next section.